Hey guys, welcome back to the channel. I have another marine or two marine ECMs coming from, actually, let me see the address because I just got it from him. His name is Tom Burres and he's from Washington State. So let me just put the information that I have from him. This is a book that he did a couple of days ago. And I had the computers in here, but it was no note in the box. So please, if you're going to send anything, make sure that you add a note with your address, email, telephone, return, everything, and concerns. The reason I ask that, sometimes when you book online, if you don't send me an email directly, it can be on the spam folder. It's very hard for me to keep up a record of that. So, and I know, it's hard to keep up with everything. So if you help me with a note, I can then quickly visit that because the bookings are, on a calendar. And then if it's 2 weeks or so after you send the computers, like in his case, I think he booked it in the 21st and the computer didn't get here till 10 days or so later. By the time I'm going to check for the bookings, it's already in the past. And then it's not worrying me or warning me about that. So without a note, and there's no way that I can do a search for bookings unless I go manually each day by day. And believe me, it's tons of them. So it's very time consuming and very hard to find a name. So if you add a note like that, you can definitely help me. All right. Thank you so much for that. All right. Let me, the computers that he sent are two MEFI 4s. Both are the same part numbers. As far as the MEFI 4 is a 12569494, and they have a different digits on the bottom numbers. Like this one is 822100071, and this one is 802991187. So very different numbers on that. Therefore, the same boat. And let me put the note in the screen so we can read it together. It's a 2002 Supra SL Indmar Assault 340, so 5.7 liters. End of last year, early this year, I have encountered issues with stumbling at higher RPM. Observe a slight fuel pressure drop at higher RPMs. Track that fuel pump, actually turn it off. While issue was occurring recently, I moved the wiring harness at the rear of the engine and the engine shut off. Track the issue to ECM failing to send a ground signal to the fuel pump when ignition is turned on. This ECM, the 0071, okay, this one. Let me put a note on that, or mark. Okay, this is the 2018. This is the one ends in 007. Was a replacement in 2017 for a different, let me just see, was a replacement for a different ECM 1187 ship as well that encountered the same issue of failing to send a ground signal to the fuel pump when the ignition is turned on. I would like to track down the component causing the ECM to encounter this issue periodically. Well, also to understand, this computer or these computers turn the fuel pump relay, not the fuel pump. So the only thing that could damage these circuits is either an old computer, let's say it can happen, or backfeeding, something in the harness that is either sending power, because the activation of that pump relay is a ground control from the computer. So if the harness is running somewhere, and when you tell me that you went to move the rear end of the harness, I moved the wiring harness at the rear of the engine, and then you shut off, that tells me that you might have a problem there that is actually damaging the computers. So when you move that, maybe in there is rubbing, like sometimes the harness with vibration and start to get pinched or cut, and that water can enter and create corrosion, but also wires can touch each other. So if a power wire is touching that ground command wire coming from the computer and then sending voltage to the computer when it's not supposed to be ever voltage in there, then that definitely will damage the computer, because the computer will expect, when the computer is not powered on, to receive a voltage of, like, let's say, a reading of voltage, because it's really no amperage going through. Because remember, we have the coil inside the relay because it's the control side. So on one side of that relay, we will have terminal 86 with power. The power will go through the relay, which is acting as a resistor. So that will bring all or any amperage that is there down. So all you see is voltage. But if you touch that with a test light or anything, it will go away or activate or actuate the relay. But the actual voltage will never go down into that wire. So the computer will use that as a diagnostics, because if it sees that voltage when it's not supposed to be there, let's say, the engine is running, it set up a fault, right? So that's how it works. It's the only way that could get damaged. It's nothing else unless it's a shorted relay, and then it's melted and it's shorted inside, right? Or you have a problem on the connection, right, in the box where the relays are, either corrosion or something that can arc, and then at the end create the same situation. All right, let's see what we have here as far as the tests that we're going to do. So I have everything ready to go. Well, I need to power my power supply. I got this computer since, I don't know, maybe 10 days ago, and I didn't know what the problems were or anything. So now I told them that I will be checking it out tonight, because I'm about to leave to Alaska. So I'm trying to help them out as much as I can. Now, let me get the Phoenix, not the Phoenix, the Diacom. For now, that's all I need, especially for what he's saying that we have here. Well, let's see first if we can establish communication. Let me make that diagram a little smaller, or actually, let me keep that like that. Let me just move the camera over this way so you can see. I gotta move it a little more. About that, guys. Excellent. Like that, I can keep that size, because I noticed that sometimes it's a little hard to read, and especially as you age, it's sometimes hard to read those little letters from the distance. And I tried to change that from the actual box of Diacom to be bigger, but I will have to change the entire font on my the screen. Well, let me see if I can do any changes in here as far as the font. I did find something. Let me power this up. If I am here, you're not going to be able to see the fuel pump, and not at this distance. If I have it there, and I unplug it. So let me plug it back in. Yes, you can see that test lighting here is for the fuel pump. So let me power this up. Yeah, we have definitely no fuel pump. Let's see if we can talk to this computer. So MEFI 1 and 4. Establish communication. That should have, oh, well, you see, guys, I'm going too fast, right? Look at this. Non-connected. All right, let's just start with the one that I think is the 2018. It was a little hard to understand his writing in there. It was replaced. It was a replacement. So I think this is the one that was. All right, so let me. This is on. So let me power this off. Let's just come back again to here. Okay, no fuel pump. Let's see if we can reestablish, or not reestablish. Let's see if we can establish communication. Yes. All right, so, okay, that actually did make a difference on the font. So let me change that again one more time. So that looks a little too big. So 16. I want to make sure that I can see everything. One more time. 14. Yeah, still is too much. It went, but let me go to 12 or 10. Okay, warning buzzers are the last one. And throwable codes. So let's see if I can do this now. What if I do bold italic on the same font? No, that looks very hard for you guys to read anything like that, right? So bold. Yeah, those are better letters, but let's see if we can make this a little bigger. 12. That is still manageable, so let's go a little more. 14. And now we can see more, or you can see more, but it is out of the screen. So I need to deselect one of these bits. Like the 24 encoder, we don't need that one in there. All these 58 cranks and everything, we can remove those two bits. Now we have everything in the screen. Hopefully that's a lot better for your eyes. There's a lot of stuff that I can deselect and rearrange, but that is okay. So we can see everything in here now. It has 5 volt codes. Oh, okay, we have a problem here, Houston. ECM calibration memory checksum failure. Okay, this makes a completely different problem because yes, when the computer has a code 51, it will not activate the fuel pump. So let's see what kind of calibration is this. 73F5. Not sure if I have that one. Let me write that down. 1 second, guys. Yeah, this computer has very low hours as well. You see 106.7 hours. Again, the calibration is 73F5. And that is not a problem here, but we do have that checksum error. I need to check that if that is the whole issue or what is going on here. If this is the problem in both computers, Tom, this might be caused by voltage spikes that will corrupt your computer. And that could potentially be a bad, it could be the bad relay that has no diode, or it could be a bad alternator, bad grounds, hard to say. All right, let me do one thing different. Let me connect the other computer to see if we have the same issue in the other computer. So let me turn this off. Yes, you guys are seeing everything perfect. And let's reconnect the now 1187. Now let's power this up. Oh, fuel pump came on. I hope you guys saw that. Yes, fuel pump is on. And let's connect. This is a completely different calibration. Yeah, this is 69B2. The part number and the computer is the same, but the calibration is different. It is a 5.7. We can see, we can see that in there. Let me just reselect because you see it's a 5.7. And this one has 471 hours. And this one has one code, pumped low open. And we can do a test. I'm going to command that fuel pump again. Fuel pump on. And it's staying on. One more time. So I will be able to move this from one computer to the other. It will transfer the hours. That's the only thing, Tom, but I don't think it matters because those are your both hours. So the computer doesn't really matter if it shows 0. What is in your boat is what is important. But yeah, I don't see anything as far as pump in here. You can see this actually activating. So let's run this computer. This is the one is, again, 11.7. No, sorry. That's the one I have disconnected. This is 1187. I can see sensor ground and fiber reference. So let me see what signal I have right here. Yeah. Yeah, I can see both injectors. Let me put the picoscope in here. Ooh, very noisy. Very, very noisy injectors. This might be a problem too. And that can be repaired. Let me, before I keep talking, let me show you. Oh, they just died. Okay, it just died on us. All right, so let me go over to Diacom. We didn't lose communication. Now we have two full codes. EST system has an open circuit. And that is definitely not in here. I mean, it's in the computer. So let me disconnect this computer. I'm going to stop this 1 second, guys. I'll be right back. All right, guys, I have the newest computer. Now, let's say clone the calibration to that because the other computer still has problems, but this one has also issues. So I will probably tell you, Tom, that your issues are most likely either main grounds or injectors really dirty. Both of these modules, the ground pads are pitted. And I have seen this all the time when you have injector that has not been serviced in a long time or ever, and then it's running a lot of amperage, and that does that situation on the computers. And also when you have bad grounds, corroded grounds, or loose grounds, and that create spikes, which that will indicate that can also corrupt calibration. Remember, when the computer is reading the EEPROM and its calibration, it's all about zeros and ones, right? Zeros, let's say, is voltage high and it stays for whatever amount of time the program is designed. And then when it goes down, it will stay low for a period of time. That is a 1. So 0, high, and it stays up, and then goes down, and it stays for almost the same amount of time, right? And then it goes up. So that is a 0 and then a 1. But then if in that process of reading the information back and forth from the microprocessor and so, it's a voltage spike, and it brings the voltage up as a spike, the computer will take that as either as a 0 or a 1, depends on whatever transition the moment of the information was, and it writes the information back to its memory wrong. And that's when you get the checksum error 51. And looking at the capture here, this computer needs to be repaired as well. As you see here, I have marked the computer as a 0071, and then this other one as at 1187, which I'm going to show you that this is the one that was with the checksum error, which is now running, but we have that, what I call multi-strike. Let me show you. I'm going to do a zoom. So I'm going to change, actually, just change the timing. I'm going to put a trigger so we can see the signals a little, at least stopping in there. And now you can see what I'm talking about. So this is exactly what we call like a multi-strike injection, and this computer don't have that. If you see the low pulse width, I put readings on the bottom so we can see the maximum on the blue channel, the minimum, and then the pulse width. When you have a clean pulse width, it will be whatever the computer is asking right now, which if we see there is 2.1 milliseconds. So I'm going to put that in the screen. So you can see there is the computer is requesting for 2.1 milliseconds. So, but right now my oscilloscope cannot read that because it's a multi-strike. If I put cursors, let me bring the red channel down, and I'm going to put cursors on here, very close to whatever is it starting and ending. We have 2.2 milliseconds. So the total amount is around what the computer is expecting to have, but we have that multi-strike. And that is something I can repair, definitely. That will make a very nice running engine, but I can correct this, but it has also, you need to do the repairs as far as sending injectors right away to reservice or replace old injectors, check your grounds, and check the alternator, which is the last part that I forgot to mention. When you have an alternator with a high AC ripple, that can also enter because none of the protections in this computer are meant to stop AC sine wave signals. So this is a DC voltage system. But remember that the alternator, when it's rotating, is actually producing an AC sine wave, which is, like this, instead of flat line DC voltage. So the triode, or the diode bridge internally in the alternator, will convert that into DC voltage. When those diodes, one of them gets bad, or multiple of them, they will start to increase the amount of AC ripple that goes into the system, and that can also create this situation. So all I'm giving you in here is recommendations. What is the problem in the boat is impossible for me to really know, but I can tell you based on my experience what could possibly be the issue. And then you need to correct that. All right, so this computer still needs to be repaired in order to correct these signals. And I will attempt to do that in order to, to make everything work properly. I'm going to stop this computer from running. And I'm going to switch to the order. So we're going to lose the communication on this one, which let me just go over to Diacom and disconnect. So now you can see in here, before I go away, let me reconnect. Let me turn the ignition back on. And here, I want to show you, okay, I have to reconnect. I left it for too long. We are reconnected, and let me see the fault codes. CST, pump low, open. We can erase these fault codes, because most definitely this will not come back, and we can see we got 0 fault codes, no ECM checksum error or anything. The hours are now the same hours that we have on the other module. Why? Because I cloned that information over to this one, and that has now the same calibration. This is the original calibration on this boat, so not a problem, and that is the original hours on the boat as well. All right, so let me disconnect now, because now we have 471.1, and I just erased this, and we got 0 fault codes. So I'm going to unplug this computer with you guys in here. I'm going to just turn this off. Again, this is the 0071. It's just backwards because it's facing down. And I'm going to put that one in there. And now this is the 1187. It run for a little bit and then it stopped running, right? And the reason I stopped the video in there is because I wanted to grab this calibration before, for any reason, this computer decides to go into checksum error. Because if I get a checksum error now, the information is no longer good and I cannot clone it. But that's the reason I did that. All right, so let me power up. And we can see fuel pump on that as well. So again, this is the one with 471 hours. So let's connect to this one. And I want you to see now the hours. This has now 471 hours. Why? Because we run the other computer for a 10th of an hour. But now we have the same amount of hours in both computers. And they have the same calibration, 69B2, which is meant for this boat. So there are no problems. But let's see now what is this computer problem, because I have not really done anything into that one, because I wanted to make sure that I grabbed that calibration and now I saved it and I can use it for his other computer, which I thought it was just a checksum error, but we can see that has issue with both injector drivers. All right, so let's run this one. It is running now. We can see the same situation, that multi-strike, but this one died. So let's see if it is stays running or not. This one has 2 faults. ESC system has an open circuit and pump load. Let's erase these faults. And it just shows us ESC has an open circuit. And this is because I might not have the feedback connected, which is not a problem. Let's see if this computer dies again or not. Let me put, oh, yep, it just did. You see? Yeah, you're seeing that synchronization, losing the synchronization, and look at the fuel pump relay. It's like you're turning the ignition on and off, and look at the injector millisecond. The computer is not really running, but it's doing this really, really bad behavior. What is that? It's hard to say. And now we lost communication, you see? But it's still doing the cycling and cycling and cycling. Definitely no good. So I'm going to turn this off one more time because I don't want to keep it on for too long. But still doing the same thing. You see, I turn it off. I'm going to completely turn off. Well, actually, let me just remove the RPM. That's probably why I was doing that. Because even though it died, I didn't remove the RPM, and that's why probably the injectors were running. All right, so I didn't see the fuel pump this time. Let's do it one more time. Yeah, I don't see now the fuel pump. Let's see if we can communicate back or not. So let me start from 0 with this one. It did detect the module. And we have one fault code only. EST circuit open. Let's see if we can command the fuel pump, because with Diacom, I can go in here in the test and run the fuel pump. But we can see how the fuel pump is no longer running. So that test should have activated the fuel pump, and it's not happening. So I'm going to stop here because I don't want to invest any time on that computer, because if I read the note from the customer, he just wants to understand what could have happened on to his boat, that now the new module got damaged as well. I did want to correct the issue, and that's what I say, this calibration. And I think this is the best approach. I will ask him, because I'm not sure if the other module can be or not repaired without really in trying, and that will definitely not be included onto the test. I already have definitely more than a test in here, and now I'm going to express that to the customer and get his approval and see what he wants to do. So I'm going to stop the video here. I hope that you like the content. You can see how much I'm actually putting into trying to help the customers and the transparency. Because I could have just told the customer, oh yeah, I can repair the computer and it's going to cost you this much, and he would probably approve it. But I don't like to do that. I like to prove what is wrong, what is bad, what it needs to be corrected or not in the video, and then do the repairs with the approval of all the customers. I always do that. So like I said, let me stop the video. I'm going to upload this, send this to him, and see how he wants to proceed. So probably and hopefully we will get a part 2. The way this other computer, the one I just put the calibration is, it will run, but it will definitely not be optimal running, and that can eventually damage the computer again. So I'm going to express that to the customer that he can see it, because this is the best way to actually prove that what it needs to be done. All right, guys. So this is going to be the end of this first part for Tom Burres in Washington, and hopefully we get a second part. So if you're here in the channel, please don't forget to subscribe. I'll see you next time. Bye-bye.